Good morning, everyone. We'll move to the next module, which is Z transform. And then I will take probability and sampling in the next after this topic. Okay. Why I started with Z transform is already we were doing some expansions in the complex variable chapter, complex integration chapter. That is why I just thought I'll continue with that. So till now we have seen Laplace transform. We also have Fourier series and Fourier transform. If we see the formula for Fourier transform and Laplace transform, they were all integration. L of f of t was integral 0 to infinity e raised to, all these were integration. It was a continuous function. But when we see Z transform, it is a discrete function. It takes single values, minus infinity to plus infinity. We don't have all the values. It takes only distinct values, just like we had discrete random variable. In the same manner, we have this Z transform as a discrete transform, where k takes the values from minus infinity to plus infinity, but not all the values from minus infinity to plus infinity. It takes only distinct values. So the formula for Z of f of k is equal to summation k varying from minus infinity to plus infinity, f of k into z raised to minus k. Yeah. So before, now when I substitute k equal to minus infinity to plus infinity, you will get in the form of a series. Okay, sometimes you may have to make use of these standard expansions, which we have done in first semester, Maclaurin series. Okay, based on that, we have some standard expansions. I'll just give you the standard expansions which are required here. So z of whatever is the function, okay, that function will come inside the summation into z raised to minus k. In Laplace transform, we had integration, e raised to minus st into f of t dt. Here, z of f of k is f of k into z raised to minus k. Whatever is the function here, that will come over here into z raised to minus k. But k is not taking all the values. It takes only distinct values from minus infinity. Like you have 0, minus 1, minus 2, minus 3 till minus infinity. And similarly, z is varying from 1, 2, 3, 4, etc. infinity. It doesn't take the values between 0 and 1. It will not take the values from 1 to 2. It takes all distinct values, all integer values, 0, 1, 2, 3, 4, etc. till infinity, or minus 1, minus 2, minus, or it takes all the values from minus infinity to plus infinity. Okay? So when I replace the values of k from minus infinity to plus infinity, you will get in the form of series. When I put a k equal to minus infinity, you will get one term. Then k equal to before that term, you will get one more term. So we will get in the form of a series. So our aim will be to combine that in the form of these type of functions. So for that, we'll just note these standard expansion. तो सबसे पहले है binomial expansion, which is 1 plus x whole raised to minus n. You have done all these, nothing new in this. So if you have 1 plus x whole raised to minus n, then we have 1 minus n. This is NC0, NC1, NC2, etc. Just like Pascal's triangle, we had NC0, NC1, etc. But here you will be having negative. If it is positive, then you can always use Pascal's triangle to calculate the expansion of a plus b whole raised to n. But when you have minus n, then we have to make use of these type of, it's the same series actually. So it's 1, if you have here plus, here minus, then we have alternate plus and minus. If you have both negative, then we have all terms to be positive. Similarly, when n is equal to minus 1, we get this series. And instead of minus, when you have plus inside, then you will get alternate plus n. If you have both negative, then everything is positive. When you have plus and minus, then you have plus and minus over here also. Okay, so these are the standard expansions. 1 plus x raised to minus n is 1 minus nx plus n into this. Similarly, 1 minus x whole raised to minus n, 1 minus x whole raised to minus 1, 1 plus x. Okay, these are the binomial expansion. Then we have, that also I gave you e raised to x expansion in while doing the residue part. So e raised to x is 1 plus x squared by 2 factorial. Sine takes all odd terms with alternate plus and minus. Cos takes all the even terms with alternate plus and minus. Then we have log of 1 plus x. Log of 1 plus x is almost similar to e raised to x. We are not having 1 in that because log 1 becomes 0. That is why we're not having that 1 over here. And then all the terms are there, other, but we don't have factorials in log function. In e raised to x, we have 1 factorial, 2 factorial, 3 factorial. But in log functions, we are not having any factorial. So it's x, and 1 is also not there because actually log 1 becomes 0. That is why we're not getting that. And log 0 is not, when x is equal to 0. When x is equal to 0, I will get 1 over here. When x is equal to 0, I will get log 1, but log 1 is 0. That is why it starts with x. So x minus x squared by 2 plus alternate plus and minus. And when I replace x by minus x, all the terms will become negative. Okay. And then this also, you can take it as standard form. It's a binomial expansion only. But when you simplify, when n is equal to 2, we can get, so when you have 1, 2, 3, 4 terms as a coefficient, then we can convert this to 1 plus x whole raised to minus 2. Okay. Already I've given these in last year only, but still I will forward again all the standard expansions. Only these expansions are required here in simplifying the Z transform. A small chapter, not a big chapter here. So even if you don't remember the expansion, at least expand and keep. Okay. You can just expand by giving the values of k varying from minus infinity to plus infinity, and then write it in the form of an expansion. If you're able to combine and bring it in the form of these terms, it's okay. Otherwise, leave it like that. That is also okay. Okay. So hope you are having these expansions. Just take down these expansions for our reference. First thing is z of f of k is summation k varying from minus infinity to plus infinity f of k z raised to minus k. Then these are standard expansions. 1 plus x raised to minus n, 1 minus x raised to minus n. All the Z transform problems are solved by using this basic formula for Z transform, Z of f of k. Just like your Laplace transform, here also we have convolution theorem, here also we have change of scale, first shifting, everything is there, but not that difficult here. It's very simple method. Just tell me when you finish writing all these expansions, I will start with the problems. First 4 and the last one is based on the binomial expansion. 1 plus x raised to minus n, 1 minus x raised to minus n, 1 minus x raised to minus 1, 1 plus x raised to minus 1, and the last one I've given is 1 minus x raised, 1 plus x raised to minus 2. And then we have e raised to x, sin x, cos x, log 1 plus x, and log 1 minus x. In most of the problems, we're making use of these binomial expansions only. In most of the problem, we're making use of 1 minus x raised to minus 1 or 1 plus x raised to minus 1 or these two. So these 4 will be the most commonly used expansions. Sometimes you get sine, log and all, not always. Very few problems have log and sine. Otherwise, all the other problems are based on these type of expansion, these binomial expansions. E raised to x, sin x, cos x, and log 1 plus x, log 1 minus x. Already these formulas are there in the SEM 3 Google Classroom, but I will just forward it here also. As a prerequisite, I had given all these expansions there. So now we'll start with the problems. The first type of problem, write the Z transform of the following sequences. And sometimes it is possible that you may not be able to combine all these series also. So then leave it like that. It is not compulsory every time you will be getting in these forms only. Sometimes you don't have those terms of the any function, then leave it like that. You don't have to bother about combining all these terms. Okay. F of k equal to first type of problem. They may not ask this type, but still I'll show you one problem based on this. So 8, 6, 4, 2, 0, 1, 3, 5, and 7. You have to find the Z transform. It is given in the form of a series. They have not, given in the form of a sequence. It is not given in the form of a function. So 8, 6, 4, 2, 0, 1, 3, 5, 7. And below 3, you put an arrow. Mostly you will be given f of k as function of k only, but sometimes they might give you the sequence and calculate, you'll be asked to calculate the Z transform of the sequence. Okay, अगर हमको ऐसा sequence दिया हुआ है, you are having some numbers 8, 6, 4, etc. 1, 5, 1, 3, 5, 7, and below 3 you are given an arrow. इसका मतलब होता है जहां पे एरो दिया है, so this value is the function, this value is for k equal to 0. जहां पे एरो दिया है वो जो वैल्यू है, this is for k equal to 0. So f of 0 equal to 3. ओके, जहां पे भी एरो दिया है उसके नीचे हमको लेना है 0. 0 का मतलब है कि when k is 0, the function takes the value 3. उसके राइट हैंड साइड में हमको लिखना है 1 and 2. When k takes the value 1, f of 1 is equal to 5. When k takes the value 2, f of k is equal to 7. And the left hand side, we have to take -1, -2, -3, -4, -5, and -6. So k takes the values from -6 to 2. When I write the summation, k will take the value from -6 to 2. So if you are given the values of f of k in the form of a sequence, then you will be having an arrow below any one of the number. So wherever arrow is given, take that as k equal to 0. Now here the arrow is given below the number 3. So which means that corresponding to this 3, this 3 is the value of the function when k is equal to 0. So when k is 0, f of 0 equal to, or f of k is equal to 3. So right hand side values are for 1 and 2. And left hand side values are for -1, -2. Just like a number line. पहले 0 लिखना है, right hand side में positive numbers and left hand side में negative numbers. Now we have to calculate the Z transform. So we are having Z of f of k. We know from the formula it is from -infinity to +infinity, f of k, z raised to -k. But in this case, k is varying from -6 to 2. Okay, according to this problem, k takes the values from -6 to 2. So -6 to 2, I'll write f of k and z raised to -k. Because we have different values for f of k, I have not written the function over there. And we are not given function. तो अभी हमको क्या करना है? When k takes the value -6, write the corresponding f of k. When k takes the value -6, f of k is equal to 8. When k takes the value -5, f of k is equal to 6. So write all the values with summation. We are having summation. तो पहले हमको लिखना है k की वैल्यू -6 के लिए. जब k takes the value -6, we know f of minus k is f of k is equal to 8. तो यहाँ पे आ जाएगा 8 into z raised to k value is -6. Okay, f of k is equal to 8. Corresponding to this -6, the value which is given in the function in the sequence f of k is 8. तो यहाँ पे f of k के बदले 8 लिखेंगे और k के बदले -6. Next number is k equal to k takes the value -5. तो यहाँ पे and when k takes the value -5, the function given is 6. So 6 into z raised to minus of -5. Next value is k takes the value -4, and corresponding to -4, the functional value is given as 4, minus of -4, plus next value is 3 -3, and corresponding value is 2. So z of -3 plus 0 z of, that is not required actually, -2 plus 1 z into whole raised to -1. Next it takes the value 0, and when it takes the value 0, we are having 3. So plus 3 into z raised to -0 plus next number tha 5. 5 into z raised to -1 plus 7 into z raised to -2. Remember, it is z raised to -k. Okay? And k takes the values in this problem from -6 to 2. So when k is -6, I have written minus of -6, minus of -5. So k takes the values -6, -5, -4, -3, -2, -1, and then 0, 1, and 2. And corresponding to these values of k, we are given f of k. So write the corresponding f of k and write in the form of a series. Just simplify and bring it in the form of a series. That's it. That will be the answer. So here we will have the answer as 8 upon z raised to 6. No, 8 into, है ना? 8 into z raised to 6, 6 into z raised to 5, 4 into z raised to 4, 2 into z cube. Next वाला हो जाएगा 0. Then we have plus z, then 3 plus 5 by z plus 7 by z. That is the answer. 7 by z square. Sorry, 7 by z square. ठीक है, तो यहाँ पे functional value is given in the form of a sequence. Functional value is given in the form of a sequence, and when you are given a sequence, you will be given an arrow. So the arrow indicates that the value, the functional value is for k equal to 0. So when k takes the value 0, the value of f of k is equal to 3. And then write all the values. Towards the right, take positive, and towards the left, you take all the negative values. And then substituting everything in the z formula, z transform formula. So z of f of k is summation. Z takes the value, k takes the value from -6 to 2. F of k is z raised to -k. So when k takes the value -6, write the corresponding f of k. When k takes the value -5, write the corresponding f of k, and so on. And then simplifying and writing it in the form of a series. Any doubt in this? Anybody? आया समझ में कैसे k की वैल्यूज लेनी है, कैसे फंक्शन लेना है? यहाँ पे f of k is not given as a function of k. We have just given that f of k is in the form of a sequence. That is why we have to consider those values 0 and negative, left hand side में negative values and right hand side में k takes the positive values. Okay. The first type of problem is it will be given in the form of a sequence. If you have any doubt, you can ask, otherwise we'll move to the next problem. The next type of problem, so most of them will not ask this direct formula, but still, if they ask, maybe they can ask in MCQ at small sequences, they can give and ask you for what is the value of z of etc. Next is given f of k is equal to 5 raised to k for k greater than or equal to 0. In the second problem, in the first problem, f of k Arrow has to be mentioned, otherwise we cannot decide. Arrow will be there in the problem when it is given as a sequence. Okay, arrow will be there. Without arrow, we cannot decide which is the value for k equal to 0. Okay? Yeah. Next function, f of k is equal to phi raised to k for k greater than or equal to 0. So if you are given a function, then we have to substitute directly in the Z transform formula. So Z of f of k is equal to, we know it is equal to, this is the basic formula, minus infinity to plus infinity, f of k, z raised to minus k. उसके बाद यहाँ पे क्या दिया हुआ है, f of k is phi raised to k and k takes the values greater than or equal to 0. तो हम कैसे लिखेंगे समेशन में, k equal to कहाँ से कहाँ तक जाएगी वैल्यूज, इट इज गिवन दैट k greater than or equal to 0. मतलब कहां से कहां तक होगी k की वैल्यू, zero to infinity. It takes the values from 0 to infinity. Function defined is phi raised to k and then z raised to minus k. Z raised to minus k. Now give the values of k equal to 0, 1, 2, 3, etc. Give the value when k is equal to 0. First value हमको k को 0 put करना है. When k is 0, ये हो जाएगा phi raised to 0, z raised to minus 0. तो कितना होगा when k is equal to 0? I will get as 1. Z phi raised to 0 is 1, z raised to 0 is also 1. तो पूरा term 1 हो जाएगा. Second में next value will be, it takes the positive values. तो next value होगी k की 1. When k is equal to 1, I will get phi raised to 1, z raised to minus 1. When k takes the value 2, phi square, z raised to minus 2. Phi cube, z raised to minus 3 plus etc. Okay, so we are giving the values of k from 0 to infinity. When k takes the value 0, phi raised to 0 will become 1, z raised to 0 will become 1. That is why the first term is 1. Second term is when k takes the value 1. When k is equal to 1, we will get phi raised to 1, z raised to minus 1. Similarly, k equal to 2, 3, etc. Just simplify and try to combine if it is possible. If it is not possible, leave it like that. तो अगर हम इसको सिंप्लीफाई करेंगे तो 1 ये हो जाएगा 5 अपॉन z. इसको हम लिख सकते हैं 5 अपॉन z द होल स्क्वायर, बिकॉज वी आर हैविंग phi square upon z square. Phi square upon z square can be written as 5 by z the whole square, and then we have 5 by z the whole cube plus etc. Okay. So now it is of the form 1 plus x square plus x cube plus etc. तो ये किसका एक्सपेंशन है, कौन से फंक्शन का एक्सपेंशन है? 1 plus x square plus x cube plus etc. कौन से फंक्शन का है ये? All the terms are positive. 1 plus x square plus x cube. It's a binomial expansion which is equal to 1 minus x whole raised to minus 1. Okay? It is 1 minus x whole raised to minus 1. So instead of x, we are having here 5 by z. Instead of x, we are having 5 by z. So now we can write this as, the series we can write it as 1 minus 5 by z whole raised to minus 1. 1 minus 5 by z whole raised to minus 1. Okay. Now this is equal to, if I take the LCM, I can write z minus 5 upon z whole raised to minus 1. If I take the LCM, I will get z minus 5 upon z. Now here we are having whole raised to minus 1, which is the reciprocal of this. So the z transform of the given function is z upon z minus 5. The z transform of the given function is z upon z minus 5. Okay, so now we have calculated the z transform of phi raised to k for k greater than or equal to 0. So k is taking the values from 0 to infinity. Then we have given the values of k from 0 to infinity. So we have got this series, and we know that 1 plus x square plus x cube plus etc. is 1 minus x whole raised to minus 1, where x is equal to phi by z here. Simplify and getting z upon z minus phi. Now, you do remember we had done in Taylor's and Lorentz expansion also. When we had phi by z, we had the condition that because to get this expansion, the condition is phi by z has to be less than 1. Then only we can expand this. If here in the Lorentz series, we had taken this and then we had done the expansion. So the same way, whatever is your x, that mod of that value has to be less than 1. Always when you use this binomial expansion, the condition which is used is mod x is less than 1. Only when mod x is less than 1, this converges to 1 minus x whole raised to minus 1. So this is called as the region of convergence, ROC. Okay, we had it in the Lorentz series expansion also. So here, whatever is your x or about whichever point the expansion is there, that function has to be less than a mod of that function has to be less than 1. So this will be called as the region of convergence, or in short, we can say it is ROC. ओके, तो पहले हमको एक्सपैंड करना है, उसके बाद जो भी हमारा एक्स है वो एक्स को मॉड एक्स इज लेस देन 1. दिस इज द कंडीशन अंडर विच यू कैन राइट दिस एक्सपेंशन एज 1 minus x raised to minus 1. Okay, only when mod x is less than 1 you can use this expansion. That is why this point is called, this function or this inequality is called as the region of convergence. That is the reason why I've taken this chapter after the complex part, so that already we have done something in Lorentz, Taylor's, and complex in the residue part. So here also you will be asked to calculate the region of convergence, but here after expansion only we are writing the region of convergence. There in Lorentz and Taylor series we used to calculate the region of convergence and then used to expand about that. यहाँ पे expansion already from the Z transform आ जाता है. तो जो भी binomial, whatever expansions we are given, for all these expansions, the condition is mod x should be less than 1. The next problem. Everywhere you calculate the region of convergence whenever you're using the expansion part. F of k is equal to 3 raised to k for k less than 0 is equal to 2 raised to k for k greater than or equal to 0. F of k is equal to 3 raised to k for k less than 0 is equal to 2 raised to k for k greater than or equal to 0. You have to find the Z transform of f of k. You have to find the Z transform of f of k. First step will be write the formula for Z of f of k. Then substitute for f of k, give the values of k and accordingly write the expansion. So first step हमेशा formula पहले लिख लो. Z of f of k is equal to summation k varying from minus infinity to plus infinity f of k z raised to minus k. Now k takes the values from minus plus, but we have it in two intervals. तो हमें इसको split करना पड़ेगा. तो first वाले में k is less than 0. k is less than 0 को हम लिख सकते हैं summation k varying from minus infinity to 0. The function defined is 3 raised to, नहीं, 0 यहाँ पे आएगा. Will 0 come here when k is less than 0? What will be the upper part of k? In the first interval, k is less than 0. Minus 1. Yes, it will come minus 1 because k is less than 0. K is less than 0, matlab 0 is not included here. So it is minus k into z raised to minus k. In the next part is k greater than or equal to 0. So k will take the values from 0 to infinity, 2 raised to k, z raised to minus k. Okay? For the first interval, k is less than 0. When k is less than 0, which means that k takes the values from minus infinity to minus 1. And when k takes the values greater than or equal to 0, then we can write k is equal to 0 to infinity. And in for k less than 0, f of k is 3 raised to k, and for k greater than or equal to 0, f of k is equal to 2 raised to k. Now use the expansion. तो यहाँ पे हम क्या करेंगे? It is starting from माइनस, हम लोग यहाँ से स्टार्ट करते हैं इसको, ठीक है? उल्टा लिखेंगे, हम लोग ऐसा लिखेंगे इसको, एक्सेट्रा प्लस, या विल स्टार्ट फ्रॉम माइनस 1. You can start from minus 1 or you can start from the last term there. Suppose I write etc. Then I can write from minus 3. अगर यहाँ पे हो जाएगा 3 raised to minus 3, z raised to 3, 3 raised to minus 2, z square, 3 raised to minus 1, z raised to 1. ये हो गया पहले वाले इसका. Plus second वाले में when k is 0, 1, when k is equal to 1, z raised to minus 1, when k equal to 2, 2 square, z raised to minus 2, plus one more we can write 2 cube, z raised to minus 3, plus etc. This is one term and this is another term. I have not written all the term because it starts from minus infinity to minus 1. इसलिए मैंने पहले etc डाल दिया. Then we have plus. We can have here starts with plus 3 raised to minus 3. When k takes the value minus 3, I've written 3 raised to minus 3, z raised to minus of minus 3. That is why we get z cube. When k takes the value minus 2, then k takes the value minus 1. When the second interval, second function, k takes the value 0, 1, 2, and 3. Simplifying this, again we have to combine this actually. So here this is equal to, so I can write this as, तो इसको कैसे लिखेंगे? Z by 3, है ना? We will have z by 3, z by 3 the whole square, z by 3 the whole cube, etc. plus etc. Then second में आ जाएगा 1 plus 2 by z, 2 by z the whole square, plus etc. This is actually in the form 1 plus x square plus x cube. This is actually x plus x square plus x cube. But we are not having any formula for, so what we'll do is we will take z by 3 common from the first term to make it as, make the first term as 1. So it is 1 plus z by 3 plus z by 3 the whole square plus etc. And the second one is say 1 plus 2 by z plus 2 by z the whole square. When you differentiate 2 and z always. In the z transform, when you use to try to write z and 2 in such a way that it looks like clear what is 2 and what is z. You can use small letter z also. Normally we use capital Z only, but still try to differentiate that. Okay. Okay, now what is this expansion? 1 plus x square plus etc. Here also 1 plus x square. So I can write these bracket terms as 1 minus z by 3 whole raised to minus 1 and यहाँ पे 1 plus sorry 1 minus 2 by z whole raised to minus 1. Okay, because of the form 1 plus x square plus x cube. We know that 1 plus x square plus x cube is 1 minus x whole raised to minus 1. So we have written both the brackets as 1 minus z by 3 whole raised to minus 1 and 1 minus 2 by z whole raised to minus 1. Simplify these. Take the LCM and simplify. So we will get z by 3 into 3 minus z upon 3 whole raised to minus 1, z minus 2 upon z whole raised to minus 1. Take the reciprocals of these. So I can write z by 3 into 3 upon 3 minus z plus z upon z minus 2. We can cancel 3 in the first term. So we can write this as z upon 3 minus z plus z upon z minus 2. Take the LCM and simplify. Take the LCM and simplify. So what will be the LCM? What is the numerator of that simplification? So when I take the LCM, I will get this as z, or I can take z common also. So z into z minus 2 plus 3 minus z upon 3 minus z into z minus 2. Or I can write this as z will get cancelled over here. Minus 3 minus 2 plus 3 is 1 divided by 3 minus z into z minus 2. Something is missing. Answer is given as 2z. How we get 2z? Is there any mistake here? They've given the answer as 2z upon 3 minus z into z minus 2. But 2 I'm not getting. I don't think I've missed out any 2 anywhere. I've taken z by 3. This is 1 minus x whole raised to minus 1. And this is 3. So 3 minus z upon 3 or 3 upon 3 minus z, z upon 3 will get cancelled. So z upon 3 minus z, z upon, I don't think. It's right? Z upon 3 minus z into z minus 2. Now tell me what will be the region of convergence, ROC. In the first expansion, what was x? In the first expansion, what was x? Z by 3. In the second expansion, the z was 2 by z. So whatever expansion we have used x. So in the first expansion, we had as 3 by z. No, z by 3, I think. No? It was z by 3, I think. In the first expansion, we had z by 3. So mod z by 3 should be less than 1. And in the second condition, we had 2 by z is less than 1. Combine these two inequalities and write it as one single inequality. How to write it as? 2 by z by 3 is less than 1. So I can write mod z is less than 3. Here 2 is less than mod z, or I can write mod z is greater than 2. Mod z is less than 3, mod z is greater than 2. Can you combine that as one inequality? Like one single inequality. How much mod z varies? Mod z 3 से कम है, mod z 2 से बड़ा है, तो where will that mod z lie? Between 2 and 3. Yes, mod z is greater than 2, but mod z is less than 3. So I can combine these two inequalities as 2 less than mod z less than 3, which is the region of convergence. Which is the region of convergence. So about whichever point we are expanding, that mod has to be less than 1. Okay, only in that condition we can write that as 1 minus x raised to minus 1 or 1 plus x raised to minus 1. So mod x has to be less than 1. In the first expansion, we had x as z by 3. In the second expansion, we had 2 by z. So mod z is less than 3, mod z is greater than 2. So the common inequality we can write is mod z lies between 2 and 3, which is called as the region of convergence. Next problem, 2 raised to mod k. Raised to mod k. We have a definition of mod as mod x is equal to x for x greater than equal to 0 and is equal to minus x for x less than 0. We have this as a definition of mod. 0 can be taken anywhere. Mod x is equal to x for x greater than or equal to 0 is equal to minus x for x less than 0. So now here we are having 2 raised to mod k. So we have to calculate z of f of k. That is equal to summation k varying from minus infinity to plus infinity f of k z raised to minus k. So we are having mod k. Since mod k is equal to x for x greater than or equal to 0 is equal to minus x, we can write this in this same as the previous one. K equal to minus infinity to minus 1, 2 raised to mod k की वैल्यू हो जाएगी k z raised to minus k plus summation k varying from 0 to infinity 2 raised to this is minus k and this is 2 raised to k z raised to minus k. Okay, k is mod x is minus x for x less than 0. So mod k will be minus k when x is less than, when k is less than 0. So when k is less than 0, mod k value is minus k. So I've replaced mod k by minus k and then z raised to minus k is already there in the formula. And then for k greater than or equal to 0, mod k is equal to k. So 2 raised to k, z raised to minus k. Now give the values of k from minus 1 to infinity and then 0 to infinity. Expand the function. Use the expansion formula and then calculate the region of convergence. So यहाँ पे put करो k की value -1, -2, -3, etc. Even though it varies from minus infinity to -1, हम लोग यहाँ से start कर सकते हैं. -1, -2, -3, etc. यहाँ पे k takes the values from 0, 1, 2, 3, etc. इसको expand करना है, then bring it in the form of 1 plus x square. तो अगर -1 से स्टार्ट किया तो ये हो जाएगा 2 raised to 1 z raised to 1. -2 हो गया तो 2 raised to 2 z square. 2 raised to 3 z cube plus when k plus etc. plus when k is equal to 0 it is 1, when k equal to 1 2 into z raised to minus 1, then k equal to 2, 2 square z raised to minus 2 plus etc. So we have this as one bracket and this as another bracket. Second bracket is already in the form of 1 plus x square plus x cube. But the first bracket is not in that form. So we can make it as 1 plus by taking 2z common. Take 2z common from the first term. So we have 2z into 1 plus 2z plus 2z the whole square plus etc. And then in the second term, we can write as 2 by z the whole square plus etc. So write the expansion. So 1 plus x square in both the brackets. So we can write this as 2z into 1 minus 2z whole raised to minus 1. And here we will get 1 minus 2 by z whole raised to minus 1. Simplify, take the LCM, etc. and see and tell me what will be the final answer. So bring that minus 1 to the denominator, simplify it, take the LCM and tell me what is the final answer. To simplify that, I take the LCM. That is equal to 2z upon 1 minus 2z. यहाँ पे अगर हम LCM लेंगे तो we will get actually z minus 2 by z whole raised to minus 1, which is also equal to 2z upon 1 minus 2z plus z upon z minus 2. Take the LCM and see what is the answer. So then again, if we want, we can take z common again. So we'll have z into 2 into z minus 2 plus 1 minus 2z divided by 1 minus 2z into z minus 2. Simplify the numerator and tell me what is the final answer. क्या आएगा न्यूमरेटर में, क्या आएगा उतना बता दो, नीचे का तो सेम ही रहने वाला है. व्हाट विल बी देयर द न्यूमरेटर? थ्री माइनस 3z है, प्लस 3z है. minus 3z आ रहा है क्या? Okay, let me check that. So if you simplify this, we will get z into 2z minus 4 plus 3 minus 2z. Okay, divided by 1 minus 2z into z minus 2. Yes. So if you simplify that, 2z will get cancelled. We'll have this 2z getting cancelled. So we have z into minus 1 divided by 1 minus 2z into z minus 2. That is it. 3z कहाँ से आया? अच्छा 4 नहीं, ये 1 है. This is 1. This is 1. Okay. This is 1. So minus 3. So minus 3z upon 1 minus 2z into z. Tell me the region of convergence also. What is the first inequality corresponding to the first series? फर्स्ट ब्रैकेट में हमने कौन से पॉइंट के अबाउट एक्सपैंड किया था? 2z. सेकेंड में हमने एक्सपैंड किया था 2/z में. तो यहाँ पे 2z है, यहाँ पे 2/z है. So mod 2z is less than 1, mod 2/z is less than 1. So tell me a single inequality. So we have mod 2z less than 1 and mod 2/z is less than 1. Anybody, can you tell me the region of convergence? 1/2z is less than 1, मतलब what will happen to mod z? Less than क्या आएगा? Mod 2z is less than 1. So what will happen to mod z less than? One by 2. Mod z is less than 1/2. And from here, we know that 2 is less than mod z or mod z is greater than 2. Then, so what will be the inequality? We won't get a proper inequality. 2 greater than, वो दो combine नहीं कर सकते. We have only greater than 2 and less than half. ऐसा कैसे possible ही नहीं है ना? So it takes all the other inequalities like greater, less than, mod z is less than half and mod z is greater than 2. मतलब क्या है? It is like the other part of the number line. When I draw this, we'll get, अगर यहाँ पे ये 0 है, ये half है और ये 2 है, तो ये बड़ा यहाँ से है और यहाँ पे है. It is not lying in between half and 2. It is less than half and greater than. So we cannot combine that, keep it as it is. Mod z is less than half and mod z is greater than 2. Is this fourth problem? I think. You can try one problem. 1/3 whole raised to k, for k greater than or equal to 0. Try this, use the formula for z of f of k, replace f of k by 1/3 raised to k. So directly I can write, I think z of f of k will be summation k varying from 0 to infinity 1/3 whole raised to k z raised to minus k. So when k takes the value 0, we'll get 1 plus When k takes the value 1, it will be 1 by 3 z raised to minus 1. It is 1 by 3 the whole square z raised to minus 2 plus etc. So we can write this as 1 upon 1 plus 1 upon 3z, 1 upon 3z the whole square plus etc. The answer for this will be 1 minus 1 by 3z whole raised to minus 1, or 3z minus 1 upon 3z whole raised to minus 1, or it is 3z upon 3z minus 1. And tell me, what is the region of convergence? What is the ROC for this problem? About whichever point we are expanding, that value, that function, that value of x should be less than 1. So here we have written 1 minus x. This x is equal to 1 by 3z. So mod of 1 by 3z has to be less than 1. Mod of 1 by 3z has to be less than 1. So tell me what has to be mod z. What is mod z from here? 1 by mod 1 by 3z is less than 1. So what is mod z? Greater than 1 by 3. Okay. So actually I'll get 1 by z is less than 3. So z has to be greater than 3. Correct. Z has to be greater than 3. That is the region of convergence. So we'll continue the next lecture with the next type of problems, etc. So it's all based on the basic definition of Z transform, that is summation f of k z raised to minus k. Substitute for f of k, give the values of k given in the problem, and then try to combine them. So mostly in all the problems, we got 1 plus x square only, which is 1 minus x whole raised to minus 1. Okay. So in the next, we'll do some other type of problems where we are having other type of functions, maybe e raised to sine or log, etc., or different type of binomial expansion, etc. That's it for today. Thank you. If you have any doubt, you can ask. Yeah, thank you.